And first presenter is Jan Karlshøj. I'll hand over to Jan now.
Yeah, thank you very much. Thank you for giving the opportunity to speak here. I would like to share some experiences we had at the Technical University of Denmark. It's not that we are unique or very special. Well, maybe we're unique, but I don't think it's that special. But I will come back to it later on the focus on openBIM. So I will talk about kind of the background and what happened with the courses, why it started, where we got the students from, which software is being used, standardization, and education, and conclusions and reflection. It's okay? Then should I hide this one? Then for the background, Denmark started an initiative back in 2007, which we called the Digital Construction Program. By 2007, it became mandatory for state buildings to hand over building models in ISC format after the design that could be used by the client, but also be used by the contractors. So being part-time then and then full-time at the university, we thought that something should happen. So there was a new education started. The Technical University of Denmark is located a little bit outside of Copenhagen. It has about 6,000 employees. There's a lot of services provided as well, because there are quite many researchers you have compared to the students. And then it's about 13,500 students coming from Denmark, but also coming from abroad, which is a benefit, but also sometimes a challenge. We started the course because this program started that you had to hand over in ISC models. There's been CAD education since 1987 at the university, and around 2003-04, we started to train people in BIM, and so this was quite natural that this advanced building design course started, that it should follow the guidelines or the demands from the requirements from the government. That has to be BIM projects and has to be handed over in IC. The requirements has later moved to include municipality building, regional buildings, and social housing. And we were quite early in doing that, which was great, but it haven't had the impact that I had hoped it would have, because people are. I must admit that the carrot is stronger than the stick, because if you force people to do something, they might not see the benefit, but they do what they should do, and are not exploring the possibilities. I've been responsible for this course for about 15 years, I think. Later it's been taken over by Tim McGinley, which has pushed it further. The idea was to integrate the openBIM in the course, so the students should do this during the course as early as possible, and use it for all disciplines. And then we are aware that the industry needed some students that had some skills in this area, and at that time there was some interest in high-rise building, not compared to what is happening in other places in the world, like in the Middle East and Asia, but to have taller buildings, and then we should have a collaboration between the different students working in different disciplines, and they should use digital tools. The course is taking place every year, so it's not every semester. It goes for 13 weeks, where the student has to use 9 hours per week, and then 3 weeks where they work full-time, estimated to be 45 hours per week. They has moved from 6 to 12, 15 people in a group, looking into building design, engineering aspects as structural engineering, MEP, project management, something related to construction, but definitely also now into sustainability, which has been a role as a material manager. And there are rules now in Denmark you have to comply with. I think it's the numbers, you really can't use the numbers. The project should be lower than 7.5 kilograms CO2 per square meter per year. It used to be 12, so it's quite a reduction. But I know that Sweden have requirements of several hundreds kilo CO2, and it's really based on how you calculate this. So the numbers is difficult to compare them. The students, the primary aspect here is not it's not a BIM course. It's a course where they use BIM tools, and they should communicate during the activity to make just one building and not make one kind of building where everything fits together, and not just make 6 different aspects of a building that are not coordinated. The course is about collaborate, evaluate, strategize what they want to do, develop, communicate, and guide the team, make support for other disciplines, and then do the modeling in using having a delivery in openBIM, and justify the solution. This building to lift is one of the project that was made many years ago in 2011, based on a concept from an architect and engineered into some level of details. Of course, it's not possible to do within this limited time that's available. And this year we moved into maybe a little bit of transforming, but using existing structures and extending them, and improving the indoor climate, but trying to use as much as the existing structure. What has been done in a particular project, you have structural models, model of the foundation, building services, architectural elements as well, and often is done in a rendered way, so it's kind of look nice. Then we have students coming from different locations, and that is nice, but we also find some challenges. We have about 50% coming from abroad, and it's very different how much they know about BIM. Some are not familiar at all with BIM, and then adding ISC standards and so forth on the top is definitely a challenge, and it also results in that we get lower, kind of better, not as good as result as you could hope. But they will at least be aware of the open standards that they have to comply with. Of course, there's a lot of peer learning because some have had several courses in this area that can train some of those that are not having the same skills, but it's definitely caused some troubles when you have a person with a structural background coming from another country who sees very limited benefits in using BIM, and only want to concentrate on the structures and not being sufficiently aware of the coordination and the need for deliver BIM models in a specific format. We require both native format and ISC, but it's only ISC files that are formally assessed. we promote them to use the open flow of data, using open standards, using IC, using IDS, using BCF, but they also have a great amount of freedom, so they only had to deliver the open formats by the end of the course, and often they tend not to look too much into these other possibilities. And this also means that we have problem with the lack of quality and have to set the bar quite low, but at least they will become aware of the open standards and the need for coordination. And it's difficult to make the students to make designs early enough, and it might become a problem in industry. And somehow it's nice that you can keep options open, but if you want to do everything at the last moment, it will often end up being causing problems, not because people are stupid, because they overlook something which is a clash, and then when you try to fix one clash, you might make another one, so you have columns in front of doors and things like that. It's really doesn't work. We have tried to set up a process many years. This is from 2008, where a associate professor tried to sketch how the student could work with models at early stage. But it's been difficult. It has improved, but it's definitely a challenge to get people to use BIM early. And this might also be due to the functionality of some of the BIM programs. About the software and how it works, we have no requirements for which tools they're using. We only have the requirements that like in the government's requirements that you have to deliver ISC files. So they have to choose their own software. Some people are using AutoCAD, Rhino, SketchUp early stage, and then move to BIM later. And it's a lot are using Revit, a few are using ArchiCAD. Some start using ArchiCAD, but forced by the rest of the team to move to Revit, and very few students are using Tekla. They are using platform provided by the software vendor where they can share data more or less in real time. And that's one of the benefits they can have by using this platform, whereas IC is you have to make an export, import in another tool, and so forth. That's seen as a barrier. And depending on the models, how they're made, how skilled you are to make models, how you divide the models and so forth, it can really be time consuming depending also, of course, of the hardware, to handle IC files. So that's also a burden. So they tend to wait to do the IC export until nearby the end of the project. But there's definitely a need for doing this as early as possible, and that's often it's too late to start the process of integrating. We have introduced CHEKdbp to do better solutions for real-time or almost real-time access to different models, and that has been a success of doing that. But it also means that IC is not used for doing this real-time collaboration. It's also, of course, a different setting when they are sitting at the university. Some are working from home, but it's very. They only have this project. They have no contracts with each other. It's different setting than in a company where you have to do maybe more projects sitting at different locations and so forth. But they appreciate being able to use Speckle and see a limitation in the IFC workflow for kind of real-time collaboration. So I very much welcome the ideas of IFC5 to have a more flexible way to do work on an integrated model or shared models, and to be able to share it during the process and not have to be using the file exchange, file-based exchange. About the standardization, some are using IDS, some are very skilled in using IDS, but the rest of the team is often having problems to do it. So often it fails. BCS is sometimes used, but as the students are co-located, they often prefer to do this just by talking together, which can be fine. But there's no track of what has been happening, and if there are some issues later, they can't identify who should be doing what. But they prefer to have the face-to-face. And some in practice are using the BCF, or a number of companies are, but there's a gap here. So to look from our side, we have to do more. If we want to have students to use IDS and BCF, we have to make it mandatory. Then the software, as I said, people are mainly using Revit. Revit is highly used in Denmark. Many of the students have worked in architectural engineering, contractors, companies. So they will use what they see there. And ISC is more seen as a archiving format, or something can be used for information drop. So it's not something that you're actually using during the process, and they tend to have the same approach when they come into trying to solve a project like this. And if there's just a few students that are used to this, they will convince the rest of the group that this is the way that they should work. So they are influenced by industry. And I think it's good that they become aware of the open standards. Also, I talked with a colleague down here that's from somewhere else that said that it's difficult. As you see, the companies they are lacking people people that have knowledge of open standards, but on the other hand, they are not promoting open standards themselves or pushing for it. So it's a difficult situation. What is else being done at the university? So in this course, we have had about 1,500 students going through the course. We also have other courses, of course. We have undergraduate and master level. And I can just show a few images from there. But the undergraduate, they are introduced to buildingSMART and Bonsai, and master level, they introduced to IC OpenShell. And for most of the courses, they focus on the FAIR data, which might first be introduced in research, but EU is having quite a lot of focus as well. I think it's a nice acronym. So FAIR is findable, accessible, interoperable, and reusable. And there's a course at the university at the entry level in Revit. There's another one using Grasshopper and Rhino and Grasshopper, but then it starts to use the openBIM, and then it can move to an advanced level where the students actually will make programs in IC OpenShell, where here there's an example that a student has collected some elements and added some CO2 emissions from each element, and they calculate how much the emissions are from each element. And this is, of course, not a tool, but it's gives the students an awareness of the what is possible with the openBIM, and a tool like IC OpenShell where they can make tools themselves. So the lessons learned, there's a great potential, but also limitation in doing collaborative real-time work. There's a need for better support for the students, but also in general how to use the open standards. I see the fair data becomes very important in Europe. At least I hope that will happen, and I see IC5 is will enable kind of real-time multidisciplinary collaboration. And then I think it's important, kind of why I decided to make a presentation here, to have a strong backup. I hope there will be from people within this community to push both for educational institutes, but also to push educational institutes from industry to make people aware of the open standards. So I think it's important that we teach openBIM in education, not and a little bit being lazy and just choose one product and one platform and use that for all courses. And I see a need for a new version of IC if we want to do more collaborative real-time work. And we have been experiencing that a tool like Speckle can help us to have this more dynamic access to model. And then you have need a cultural shift, which is in Denmark is not really happening in the industry. Of course, as you have to deliver IC, people are aware of it, but it hesitates a little bit to use it for real work. So it's more kind of a delivery that you have to deliver, and they will stay in one platform which is heavily used in Denmark, which has benefits, but also some drawbacks. So what can we do as a community? I think we should, as educators, educational institute, we should be aware of kind of how we can prepare students for this. I think the universities or architecture schools and so forth, they should at least be aware of openBIM, and I would like them to promote it, or at least tell people about this. And I would like you, if it's possible, to influence what is happening at schools. If you are in an advisory board or something like that, or industrial organization, that you push for openBIM as well at different universities or architecture school or educational institutes. And as I showed, we had at least 3 courses our university, which is teaching and demanding use of openBIM. Yeah. So that was my final slide. So just a few minutes for questions.
Hello, my name is Nejad. Thank you for the beautiful presentation. I didn't notice, but is there a place where students can learn coding? For example, I'm a BIM manager, and I cannot do my job without programming. Did you?
Yeah, but the students and use some of the tutorial for IC OpenShell. So that's the
that's the part where they learn coding.
And then they have as another course in Python, which is mandatory now at an entry level. So they will have some knowledge about Python before they go to an advanced course where they use Python together with IC OpenShell.
Thank you.
Yeah.
Thank you for the presentation. Are there any kind of minimum requirements for students to apply to this master? Because especially for coordination, usually the background of students isn't leveled, and there's a need of a minimum fundamental knowledge about design, construction processes, and so on. So the question is if you have any kind of requirements for that. And also, any of these subjects been included also in traditional, more traditional civil, structural engineer, architectural courses in the university?
Yeah, it's difficult to say what is happening in the future, but so far it's mandatory for all architectural engineering students and civil engineering students at the university, which is nice. But on the other hand, we have to accept all, and they can be accepted because they have great skills in their bachelor, where they had some structural engineering or MEP. But there's no guarantee that they had any skills in BIM or being aware of openBIM. So that's one of the challenges. But they might be, they can be perfect students for structural design courses and so forth. But as it's mandatory, this course for all students, it's really a mix of students with kind of high level of skills, but also with a very low level of skill. But at least they become aware of the possibilities. But they also see some of the burdens because they are not maybe not being trained at all before having this course, and then it's a steep learning curve. We have offered sometimes to have a beginning of the course. We'll offer some additional training, but it seems to be difficult to attract students, maybe because they think it's later in the process they have to do it, and then when they have to do it, it's a bit too late, so they will put the burden on some other students that will have to do some of the modeling.
Okay,
Yeah.
thank you very much, Jan.
Yeah.
The next presentation is Christian Frey.
So yeah, welcome to my presentation. I have given a teaser already on Monday in the plenary about the asset administration shell. And today I would give you more a deep dive that you get a better understanding what it means and how it works together, especially in the openBIM context. Short repetition about the digital twin. On one hand, we have what you all know, the digital construction twin, which describe the building in IFC wall, IFC ceiling, and all these IFC elements. This is the standard, but this is not all. The building needs much more. It needs products. It needs products that has to be they are getting more and more complex, especially when it comes to the technical building equipment, and these products need also a description. That's why we need the asset administration shell for. And at the end of the day, because the BIM model, the IFC model, and the product description is just static data. But what we need in the operational phase is dynamic data. So in order to do this, we bring this together, and I call this the performance twin. And so why do we need it? I show you here, because 80% of the life cycle cost of your building is in the operational phase. So if you want to do savings, you better save them here because you have a higher impact. And when we look at the traditional projects, then we see that we always have a gap, a loss of information between design and construction, and also from construction to operation. I think it's even deeper. So now if we follow the BIM process 19650, then I think we can do a better job, because we have the common data environment where we have everybody has access to the same information, and you can also use it for later on. And I think we should already increase this with the operation that we have the performance twin, where we have a leap already on information that we get directly from the beginning, because we can use the asset administration shell. And how this will work, I will show you later. What you see here is the just for the explanation again, we have the IFC, which is a skeleton, which is the building, and we have also the AAS, which I call the nerve system of your building, of the technical building equipment. And bringing this together, and this is the cool thing, that you get the information not only about the asset, but also where it is located. So if you have, let's say, 1,000 of present smoke detectors in this building, you have the exact location of each smoke detector when you click it in the model. And with this, you get the real information, the live information from this location. And this is how the asset administration shell, what it is based on. It is based on existing standards. So we use for the semantic, for example, E-class. We use for the transmission, we have Web of Things, we have OPC UA, and all these standards, they are already existing. So there's nothing new. It's just that we use it. And what you see in the on the left side, you have this digital nameplate, the documentation, carbon footprint, real-time data. These are called submodels. So the asset administration shell is based on submodels that are defined as a template and that you can fulfill with your manufacturing, manufacturing data. And next to this, you also have, you see on the right side, this simulation and advanced 3D, CAD data that you can use for, let's say, for your service or commissioning personnel, in order to give them deeper information than what is needed for the standard. Again, here the asset administration shell, it's an IEC standard. So it's nothing that is proprietary, it's open. You have a, I don't know whether I have a beamer here. Okay, you have a type. So you start with a type in the blending phase, and as soon the asset is ordered and installed, you have an instance of it. And as you see here, you have also your physical asset, and based on this, you have the link to the physical object via the AAS. So the AAS holds the information about your physical object. And the good thing is, you can also use it for your digital product passport. So you have a magics code where you identify your product in the field, and then you get all the information that you need for your digital product passport. And we call this a DPP 4.0 because this is an invention coming out of, or the system coming out of the industry 4.0. And we use it also now in the building industry. And the good thing is, this is not a GS1 code, so it's license free, it's an ID link. It's also standard. And then you get all the information that are legally required for the digital product passport by the EU regulation. Next to this, again, you have other submodels that you can use to create new business cases in the operation, or also to improve your commissioning time and all this stuff. Because this is exactly what the problem is. You have a lot of information, and then you hand it over to your facility manager, and what happens? He's looking at this stuff, but he doesn't get what he needs. And that's why we say we have to bring this together, so we have the coordinated information of the asset. Where are they installed? Where is the location? And when you have found the location, what are, for example, maintenance manuals? Okay. What you see here. Oh, sorry. Again here. Just a second. Okay. So what you see here is, this is a product, this is an energy monitor. This is a product from Siemens, of course, and but it can be any product because the asset administration shell is vendor neutral. So all the data, how they are arranged, it's in a standard and is vendor neutral. The blue stuff here, these are so-called submodels, and within a submodel you have the submodel content. So all the information that comes with the product, what you normally have on your data sheet, for example. But it is even better. We also have now here a Modbus connection. We can also have a BACnet connection or KNX connection. So you can read out live data from your product of the location where the product is installed. So for example, if you have this energy monitor, you get the exact live data coming from the product. And this is a big advantage. It's not, this is what I mean with dynamic, okay, in the operation. This can be, in this case, it was energy monitoring, but it can be also temperature, it can be humidity, it can be presence, whatever you would like to retrieve from your product in during the life cycle in operation. And then you can store these data, doing historical analysis, see when something is running out of the standard. And for us, this is important for autonomous buildings. So if you, we need all this information because a building is getting more and more complex with all these sensors we have inside the building, with the operational phase, with reducing the energy consumption, all this stuff. We need to have this data in order to increase the performance. And another advantage is, you see this presence detector. And my example is always, how can we use also AI in this field? And the thing is, this presence detector is installed in the toilet. When you enter the toilet, you go in and the light goes on. To make this happen today, somebody has to sit down and program a controller. So input one of the controller, which is the presence detector. If it goes on, you have to switch on for outputs for the lights. This can be done by AI because you have the location and we have a space, in this case a toilet, where the AI finds this presence detector and it finds the 4 lamps. And it knows exactly by wiring where is the controller of this. And it does a pre-programming of the controller even before commissioning. And that's why what you saw before, when I have this leap in my performance twin, this is exactly how we start. We start optimized already from day one. And not struggling around and finding all these things. Where are they? You know all these problems. Okay, so this is a big advantage to have the asset and the location, and based on the location, we can retrieve more information and do more things, especially with AI now coming up. Again here, a bit more details on the digital product passport. As I said, you have your digital nameplate and your identifier, which is not GS1 in this case. It's, as I said, the ID link is open source. It can be provided by IDTA, which is the host, actually the standardization organization by from the asset administration shell. It can be hosted by you as a manufacturer of the product. So you are not forced to use a GS1 code here. Now, from the process, how does it work? We have the, we have the type data that sets a requirement. It can be in the IDS, okay, where you say, I would like to have a presence detector. I would like to have a temperature sensor. I would like to have this and this. But you describe it vendor neutral. That's why I mean with type. And when your ERP system is going to order the product, then it becomes an instance. And with the instance, you have the serial number, you have the version number of the firmware, for example, and all this stuff. And then it goes into the runtime, and you see here from the IFC data, I call this a slim BIM. So what I would like to see is that we can reduce the BIM model to the necessary objects. And in many cases, IFC space is enough. Okay, I don't need to know about the IFC wall or IFC ceiling for the building operation. IFC space is good for me. And what's also cool for rebuild or demolition, you also have now your instance data. You know exactly what you can reuse of your product. With this, you may be also able to reduce your carbon footprint because if you can reuse, let's say 80% of the product, you may reduce it already in the beginning. So that's the idea behind. And we started with this. You see, there is a cooperation agreement between the IDTA, which is the Industrial Digital Twin Association, because the industry looks much more on performance than we do in the building sector. And so we started to have this agreement, not even a year ago. It was signed by Clive at this time, and the managing director of IDTA, Mike Billman, he was also here on Monday. And we started working. And the interesting thing is, it's also it's all open source, okay? You don't have to rely on any proprietary or vendor logins or whatever. It's all open source. You can use it, you can modify it as you want. And as I said, we started working, and already in December, not even 3 months later, we had the first guideline how to bring IFC and AAS together. We did a review. A new version came out in April, and there's also English version that you can download for free on the IDTA website. On the buildingSMART website, buildingSMART Germany, you also have the document you can download for free called Leitfaden to get a deeper understanding on how IFC and AAS comes together. So, yeah, not everything is perfect yet. So we have still some gaps that I have described here in the 5 points. The life cycle is what we have to think about. We have to think, what does a facility manager need at the end for efficient operation? And this must be, we have no link between the design, planning, and operational data management. And this is what I hope we will get with the IAS and the location from the BIM model. And Another problem is, well, we have the IFC. Actually, IFC is enough. But there are also a lot of proprietary standards around that convert it into IFC, but they do not take the AAS in their thinking at the moment. So we have to work on that. Also, the tooling infrastructure is not where it could be. I mean, as I said, just 1 year now where we started. But we have working groups in buildingSMART Germany, but also at the ITTA in order to work on it. We have, of course, a fragmented stakeholder landscape. We have planners, we have operators, integrators, and they all have their own goals. But at the end of the day, the customer has to decide what he wants. And if he demands it, then we have to deliver. Okay. About the pilot, we are currently working on with the University of the Bundeswehr in Munich on a pilot project. So we can give you a demonstrator, because everybody's, have you already implemented it? I say, hey, sorry, we started a year ago, but we work now on this implementation. So we can give you a demonstration, I would say, in next 2 months. We have 2 master students working on it, and they show it in live, how it works together. Also, the airport Vienna has a high interest on exactly this solution. So they are also supporting us. Christoph Eichler, he's also here. He is supporting us here, and we have a clear idea how we can work together, buildingSMART International and the IDTA. So now the question is always, what's in for me? What's in for you? Well, we enrich the BIM model. We use the data that is in the BIM model, and we bring in the live data. We bring in all the information that comes from the technical building equipment, not only from the walls and all this stuff. No, the technical building equipment, you know exactly what you will get, and this is important for an efficient facility management. We have a standardized handover process. Everything is machine readable. You have the QR code. You get all the information from the asset. You know where it is located, and this is what it's a big advantage. A lot of time saving in the facility management. It's all vendor neutral, and it's interoperable asset models. So no matter who is your manufacturer, or even if a product is no longer available, you can replace it by another manufacturer without changing anything, because the data access is standardized. It gives also the opportunity for new services. New startups will come up and see, well, we have now access to all the data. We know where it is. We have we can do predictive maintenance. We can do also remote diagnostic, ESG reporting. All these things are now possible based on the live data that you get out of the building. And yeah, the digital product passport, I named it the Energy Performance of Building Directive, something that is requested by the EU regulations. So you can prove that you have all this already in with the asset administration show. Now, what we are focusing on? We need, of course, to convince people to use it. So that's why we have the use cases I mentioned before, this operational demonstrator, and we need also the tooling stuff. We all work on this. We have our we need to prove also the return of invest. Also, I think it's not an investment. It's really something that you need anyway. So we need to engage also the manufacturers, that they provide this information in this AAS standard. There are already a lot of them. When you go to the IDT website, you see all the members that are coming more or less from the industry, but it will be more and more also getting in from the building side, from the technical building equipment side. Yeah, we have to prove in order to convince the customers, and they also need to request it. So if they ask for it, DPP for 0, for example, then it is easy to add the submodel for the IFC connection. If the DPP is based on the AES, it's just another submodel for IFC connection. Yeah, and education. The universities, the high schools, they have to teach that this is the future we are going to, and they have to implement it, and also bring in a new spirit in, let's say, old thinking companies. Sorry for that, but that's how it is. We did it the last 20 years. Why should we change? And this is really a way to change. And education is something that is really important. I know it's still confusing, but sooner or later, when we have the demonstrators and all the stuff, when you can see how you can do a carbon footprint calculation, because you have all the data machine readable available. It's not a PDF. It's not an Excel sheet that you use. You use a JSON file or a JSON program that does all the calculation. And that's why I'm saying stop working with PDFs or Excel files and stuff like that. Go digital. Make it real. And I hope for your support. And if you have any questions, I'm happy to try to answer them.
So thank you very much. A preamble. As I was in Siemens Zug headquarters in Switzerland, I saw in the lobby 2 tablets, iPads. And you could, using virtual reality, you could scan the code and see every Siemens product in the building. And need just to program output of those switches and products from Siemens in this virtual reality environment, and then augmented reality environment, and then they can really see or go to the to the product, do maintenance, or get the information. Is there anything in this direction in Siemens? So using the augmented reality.
Yeah, we work together with a company called Navis. They do the point cloud scanning, right? And what we already did is you do a scanning, let's say, in the several phases of when you build the building. And with this, you can actually look behind the ceiling. And this is a big advantage. If you have a ceiling like here, there's a lot of technical building equipment behind it. And now you look, let's say, for a controller. Where is it? You start opening here, you look inside, and then you don't see it. Then you open here, you open there. And with this height of the ceiling, it's you need special equipment for that. So with what you just said, augmented reality, you can look behind, you can see even then the live data of, let's say, a pump that is somewhere running. Okay, you see all this information. That's exactly the idea we have. We have a demonstrator in our headquarters, as you said. It's with our Building X lifecycle twin, where you can have this information available. Yeah. But this was a direct backnet connection. It was not standardized. It was proprietary connection. Okay, what I'm talking here is a standard that you have also, even if you have, let's say, a competitor product inside, that you can access it the same way. Okay, of course, in our Siemens building, we only use our Siemens products. So, some more questions?
Yeah, thank you for the presentation. One thing you mentioned, IFCs and IDS a lot, but you didn't mention BCF for communication. And I know that facility management, one of the big things is like creating tickets and, you know, being able to follow the maintenance and operation on site. So how do you make sure that those people, everything that's happening on your building will be still like open standards for the future?
I don't make it happen. You have to make it happen. Because it's really the community. What I'm saying here is we have a standardized access to data. And how you connect to the data, that's something that you have to fulfill in your PCF or whatever. Could be a submodel. Could be a submodel saying, okay, for ticketing, if something goes wrong, you create a ticket with a submodel. It's not defined yet, but we can define it. That's a good thing about the AAS. It's really open. You know, you're not limited to anything. You can create a new submodel, and we already have about 100 submodels available for this standard. Many of them are used in the industry, let's say for the shop floor, but we can also add a submodel for that. So it's just starting, as I said. Okay, there was
Time for one more question.
Yeah, thank you for a very interesting presentation. How to become AAS compliant? Can you use your old equipment, or do you, will there be interfaces from devices that are not compliant with the shell, or how do you see it? Is it do people have to replace everything, or it can be something added on top, or a different interface, or a other possibility?
That's a good question, actually, and we have the data is already there. What you have to do is you have to create an AASX file for the asset administration shell, and there are already companies providing this as a service, like Cadenas, for example, where you have, when you go to Cadenas, you have a one-click AAS generator. We also have an AAS generator by IDTA. You can download it, and then you connect it via an API to your existing data or to eClass and generate the AASX file. Then you have it according to the standard. So that's not a big deal. I mean, many of any manufacturer at least has his own database. But what we do is we connect it to an AASX server where you as a customer have then connection to. Okay, yeah, thank you very much for listening. And if you have more questions, I will be around. You will find me. Thank you.
Thank you, Christian. The next presentation is Piotr Dymarski. Okay, and his colleagues.
Hello, everyone. My name is Piotr Dymarski, and I work for the Polish construction company called Mostostal Warszawa. And I'm today with my two colleagues.
Hello, my name is Borja Martínez. I work for CHEKdbp in Belgium, and I'm going to give you a brief review of Czech toolkit and workflow.
Good day to everyone. My name is Trajche Stojanov. I'm an architect from Frey, North Macedonia, involved in Czech project.
I also represent a Polish chapter of buildingSMART conference, of buildingSMART, and today we will present some outcomes of European research projects related to the digital building permits. Before we start, I would like to show you one video to explain why we took up the topic related to the digital building permits.
They're all smart.
Okay, I think that this explains very well our presentation. So now I would like to emphasize that the Czech project is not the only one that conduct the development of this area. We have two ongoing other projects, Accord and DigiChecks, just to show you that there are other consortia that also make research in this topic. The Czech consortium is a diverse group of partners. You can see on this slide how we are divided and what kind of stakeholders we represent. But the most important is that we have 4 municipalities who are our end users and are involved in the developing and testing our tools. So I would like to start with the challenges that we face. So at the beginning of the projects, we made brainstorming with our partners from the municipalities, and we defined the following changes. First, currently we have manual process. This means we rely on traditional paper-based workflows, which are often slow and efficient. Next, there are ambiguous regulations. This can lead to confusion and delays, as rules are often open to interpretation. You can imagine that even we had 2 municipalities from the one country, and we had discussions how to interpret some rules. We also think there is also a significant lack of transparency. The process can feel like a black box, making it difficult to track the status of the application or understand the decision-making process. Furthermore, there is a lack of technology. We don't have a necessary software or tools to streamline and facilitate the entire building process. And finally, there is a lack of awareness about the possibilities of the modern BIM-based processes that can offer to make their life easier. I'm talking about the workers from the municipalities and all partners involved in the process in the building permit process. Next slide. And a few words about the different perspective between the designers and municipalities. The designers acting on behalf of the investors aims for the efficiency. So they want to submit the minimum amount of documentation and get approval as fast as possible. And the municipality has a different perspective because they have to take care about the safety and regulation compliance. So they expect well-organized and well-prepared documentation to properly assess the projects. However, both sides would like to have this process very quickly because for the designers and investors is the cost, is the saving, is the goal is to save the money. And for the city, it's also important to grow up the city and has this process smooth. So next slide. And this is the challenges that we had in our project. So at the beginning of the project, it was very challenging to define process in different municipalities of the building regulations. And at the end of the project, it was very challenging to test all 11 software tools with different workers from different municipalities. And now you can see our demo buildings. This is our real cases that were involved for testing the tools. And now my colleague Borja will talk more about the technical aspects.
Thank you, Peter. Well, in this project, we developed 4 pilot cases with different type of buildings and surroundings depending on the municipality, from a public educational facility to a single detached family house, and a multi-story residential building and a mixed-use building. This is the check toolkit. We had 3 main tools for the check-ins, which are BCMap, developed by Virtual City Systems. This is a GIS-based platform. SciP Urban and Verify 3D, IFC BIM-based tools. And we have other supporting tools for several tasks, like georeference assessment, converters, and 5 format checkers, like the Express Schema Checker and IDS Checker. And also we have the exporter, digital signature, converters, etc. And all working around a common data environment, which was provided by SciP. This is a brief schema of the workflow from the very beginning, where we collected the initial data, both from the municipalities, and finalizing the process with the signature of the project and share it in the common data environment for final assessment and cross-checking by the municipalities. Here is a zoom into the workflow. The first step is the collecting data. We could use the BCMap toolkit to get digital terrain model and also surrounding information. Then we could transform this information in an open format, GML, into an IFC developed by RDF from Peter. Hello, you're here. And after doing the conversion, we had the main information to begin with the development of the building, the pilots. Once we finish the pilots, we have to upload all the information in the common data environment, which is the BIM Server Center provided by SciP. After that, we could connect with georeference assessment tools like IFC, GeoRef, and also with BCMap. And after doing that assessment, we can begin with the urban regulation, making use of the main checking tools, which I mentioned before. And if everything is right, we can, in the 7th step, do the signature of the IFC files and then upload them to the common data environment to share the information with the municipalities, to do all the performance cross-checkings and give the permit if it's possible. This is a schema describing the common data environment, which lets all the stakeholders in the project to go into the files, which guarantees the transparency of all the process. The applications or the tools can connect via Open API to the platform. So everything is here stuck, let's say. We have implemented several regulations with different levels of difficulty and different approaches depending on the software that you mentioned. In this case, we are seeing setbacks and building height depending on the limits of the plot. Another 2 examples. Here we have the number of required parking plots depending on the building, and the height also of the building depending on the surroundings. For the development or for the tools, we have used several types of information, of data. We have used graphical data, we have used parametric, and we have taken into account the surroundings or the context of the buildings. These are two more examples, which is the building height of the maximum number of floors above level and the buildability index. I have to say that the CHEK toolkit, it's open and it's scalable, letting the developers implement more regulations defined by the urban plans. During a period of 6 weeks, we have been working hand by hand with the municipalities, Praga in Czechia, Lisbon and Villanova de Gaia in Portugal, and Ascoli Piceno in Italy. After working with them, we had a valuable feedback from the user that let us get us very important information to improve for future developments. These are the description of two scenarios. We have we did the assessment or the workflow in the first scenario for a new building construction, and also repeated the process for a renovation scenario. In the case of Gaia, we added a new volume at the building. And in the case of Prague, we added also a new volume at the rooftop. For Lisbon, we extended the backyard to add a restaurant. And for Ascoli Piceno, we included at the top a new volume also to include a gym. We repeated the whole workflow with the two municipalities with 4 pilots and with the 2 scenarios. So we repeated it 8 times. Well, going deeper into the tools, this is SciP Urban. This is a BIM-based tool. It works standalone. You have to install it in your computer. And it's designed specifically for designers. So the municipalities will not work directly with them, okay? It needs IFC files, you federate them, and you will need to, as a designer, to create auxiliary graphical elements. I have to say that the regulation must be created in advance by the developers. The same as in the case of the BC maps, regulations based on IDS format must be developed in advance by the developers. In the case of BC map, this is a totally automatic checking tool, and it is web-based, okay? In the case of 3D, Verified 3D, developed by Synapse, this is another IFC BIM-based tool. It works in the web also. You can see the URL there, and you need to implement the rules in advance before doing the automatic checking. And these are the auxiliary tools. In this case, we can see the converters, both from IFC to GIS and the reverse one. The conversion from GIS to BIM is made by RDF, and the opposite side, BIM to GIS, is a tool developed by the TUD. And also you have the both tools, IFC GeoRef and BCMap, to check the georeference of the plots. And here, finalizing the presentation of the tools, you have the exported, which is a plugin that you can install in Revit, and you have also the Stellar digital signature to sign the IFC files. And with this, I finish I give the presentation.
Thank you, Borja. I will do it this way. Okay, I'm not that technology advanced. Sorry about that. So it's okay. Thank you. The core purpose, the most important goal of CHEK project was to provide digital toolkit in order to support digital building permits, and I think that we greatly achieved that goal as we tested it, and now here are the results. So I can say that the key achievements of CHEKdbp is that we validated the CHEKdbp, proposed CHEKdbp in a wider context, in a wider environment, meaning that we had 4 municipalities in various parts of Europe, which means various legislatives. Also, we took into consideration 2 scenarios: new construction and renovation. Also, 4 building types. Then we exercised end-to-end the Czech digital tool chain, which means that we validated the whole steps involving these digital tools. What is very important is that we didn't run just a lab demo. We recreated a realistic workflow, meaning that real permitting steps were taken into account with real designers and real permitting officers. So demonstration participants, we all confirmed the conceptual value of CHEKdbp, which is based on model-centric, standard-based approach for digital building permits. Now, as a strong standout, as our biggest probably strength of the CHEKdbp is that we enabled the 3D geospatial context when reviewing the models, which gave the designers, but also permit officers, but also designers tools to fully understand the compliance of the models against the legislative. At the end, we made surveys. We took the results, and this is the feedback from the biggest demonstration group, which were the municipal permitting officers, which are more than 20. So what worked well? They said, sorry, one before. Yes, what worked well, that is the 3D visualization in geospatial context, because this enabled the permitting officers to be fully aware of where the design requirements are not met, why they fail, and so on. Then also they were very grateful about the tutorials and live support during the demos, because that boosted their confidence. And they also confirmed the usability of the CHEKdbp tools, especially for the core task when doing reviewing. But what needs to improve? They required more rules to be encoded, because we used just limited number of rules. Also, rules needs to be transparent, which means that the rules logic needs to be presented along with the list with links to the regulative articles, to the building code. Then they asked for more strong technical integration and stability issues fixed. At the end, the lack of immediate efficiency gains were not that easily recognizable, but that's because of the various limitations that we had in order to make CHEKdbp more mature. Regarding the designers, we generally reported more or less the same feedback. What worked well? We had clear IFC expectation, which means in advance we knew very well what we need to deliver. Also, possibility to do the pre-check and self-check of the models were very precious, because we were in position very early in the design process to see what is causing errors to our model, and also to correct the errors and to submit finalized models which were with high quality. What worked well also for us is the simple visual tools that supported efficiency. What needs to improve? We reported more or less the same feedback as municipal permitting officer, so I will not repeat that. Please, next. Regarding the matrix, we had some problems to collect the matrix like should be, but because the data were very various, let's say, but the strong KPIs metrics that we rely to were time savings and error reduction. Now, regarding the time savings, that was very obvious. Designers had a lot of savings because of the pre-checking tools that we had in our disposal. Regarding the municipal work, they reported various numbers and they also pointed some various time-saving events. Regarding the error reduction, again, because we had clear IFC specifications along with pre-checks, we were in position to very early to detect the problems and then to rectify them, to correct them before final submission. So pre-checks are very valuable for the designers because that will bring the full benefits of digital building permits. Regarding the document simplification, we tried to put a lot of requirements into BIM models. Our aim was to have somewhere between 50 and 70% at the beginning of the project, but these are the numbers that we received, starting from 30 to 60%. And one of the reasons why the numbers are like this is because usually legislative in various municipalities have some limitation and specific on external review. For example, there is a strong demand for 2D drawings, 2D documents, and completely other reviewing steps when submitting for building permit. Next. Regarding the rules performance, we had very high numbers, but unfortunately we didn't get above 95% KPI. The percentages were from 70 to 90. And the reason why is this so is because we had a limited number of rules. Please, next. We also submitted feedback about the core checking applications like Virtual City Map, then City Solibri checkpoint. We had very democratic approach in this case from the very beginning because we used not one, but three different checking software. With each of these application, they had different strength, let's say, and maybe different approach. And this is very important and proved to be beneficial for us because we use three companies with different visions how to solve the problems. During the demos, all three applications complemented each other. Please, next. So as a conclusion, what we can say at the end of the demonstration process, first of all, we proved the feasibility of the CHEKdbp workflow, which is again model-centric based on openBIM standards. During the demonstration, we also saw some gaps that hinder the production use, which means that additional activity needs to be taken into consideration if we want to bring CHEKdbp on more mature level. There are a couple of very important issues that have appeared. For example, in order everything to be checked for building permit, that means that BIM models needs to be fully detailed, and that may be a professional load on designers' side because they will have to put everything inside of the BIM models. And as I said, sometimes that is not possible due to some legal limitations. But also there is a huge potential for new market niches because models needs to be prepared in a certain way that in order to be checked for digital permitting. Now, resilience and adaptability of the technical sector is needed on high level in order to operate efficiently. Please, next. What are the challenges that we face during the CHEK project? First of all, regarding the BIM and GIS, BIM and GIS must to be connected very tightly, which means that for BIM models to be checked, we need to have proper georeferencing of the IFC model. Then also we need spatial context to be presented in a way that can be used, which means conversion between BIM and GIS must be tight. Also, a technical challenge involving the connection of the already existing GIS platforms that were existing on municipal level. Regarding the interoperability, we face some loss of semantics. We also saw that input-output conversion is very brittle. And we had some collaboration gaps. The collaboration was fully inside of BIM Server Center that functioned as CD of CHEKdbp project. Now, we need, regarding the standards adoption, we adopted, definitely we relied on IFC. Specifically, we used IFC for Addendum 2 standard. We relied also on IDS for checking the validity, let's say, of the models. BIM and GIS needs to work together, because those are two very different technologies, and they differ heavily in the way how they present the data, level of details, and so on. Also, one of maybe major hurdle was regarding the legislation. Regulation, usually the legal aspects of the building permitting requires different approaches, and it's not streamlined for using openBIM. Next slide, please. As I said, we use IFC as a submission backbone. That standard is very mature and played very nicely in our case. IDS we used as an information requirements gate, but we have some recommendation in order to it would be very nice to this standard to evolve from just checking the presence of certain attributes to checking the basic correctness, at least, to supplement the checking of the models and checking of the rules. We did validation of Express schema. Also, we had tool IFC checker, again produced by RDF, that functioned very well. Regarding the feedback and our constructive proposals, it's very evident that we need IFC standard for regulatory domain, because that will make our life much easier. Not only our life, but will make digital building permits more effective and more realistic. As I said, IDS standard needs to evolve further because it's not taking into account geometric constraints, and also there are some other limitations regarding the attributes. There is a huge demand for standardizing the IFC digital signature. This was huge demand from the municipalities, because there is a need for BIM models to be legally valid and also to be authenticated. Regarding the buildingSMART International Validation Service, we face that BIM models often report issues regarding this check, and as far as we know, that is something on relation between buildingSMART and BIM software vendors, something that needs to be rectified. Next. Now, regarding the replication and scalability of CHEK results, first of all, as I said, CHEK, we proved the conceptual value of the CHEKdbp, but we were limited in many ways. In order to be replicated and scaled for production use, first of all, there is a need to to harmonize urban planning regulations. Also, there is a need for municipalities to have interface to outer IDS for each parcel, because IDS is very important for pre-checks. Also, we should have strong georeferencing and interoperability about all the platforms and software, because obviously we will need more tools to be integrated among themselves. And of course, there is a huge need of common data environment that will serve as a single source of truth and will connect all these tools together. Regarding the scalability, there is a need of registry of rules that will be updated in certain packs, like rule sets. We need signature and validation service, standardized document kit that will, including templates, libraries, everything that can benefit can support the digital building permit process, and also multi-tenant architecture. So the last slide, please. So please visit CHEKdbp.eu, since all the deliverables are there. You can learn more and see more about the tools that we produced, and everything is publicly accessible and available. Thank you very much. Do we have time for questions?
It's lunchtime now. We can take one question if anyone has a burning question.
Mr. Nick Nisbet.
It's for all of you. I'd just really like to ask about this need to harmonize urban planning regulations and create a shared rule registry. Have you any belief that that's realistic?
I have an opinion. I think this is not really realistic, but it would be very helpful. Because in each municipality, you can, we had the problem with the building height. In every municipality, they have different rules, different restrictions. So it's very difficult, but it would be very helpful. So I don't know if you have.
As a political initiative about harmonizing the regulation, I think it's possible, especially for European Union, because usually matters are dealt as a union. So, but that's why we have a regulatory room in buildingSMART International to push everything in that direction.
Thank you very much. That concludes today's session.